Planetary boundaries are the invisible lines that define the safe operating space for humanity within our planet's ecosystems. They were first introduced in 2009 by a group of Earth system scientists led by Johan Rockström and Will Steffen. The concept sought to quantify the key Earth system processes and parameters that, if significantly altered or exceeded, could lead to irreversible and detrimental changes for both Earth and its inhabitants. The fundamental idea revolves around the concept of a safe zone, within which human civilization has thrived for thousands of years. The stability and conditions that characterize the last 10,000 years, a period known as the Holocene epoch, provided the foundation for the development of human societies, agriculture, and economies. During this epoch, the Earth's systems maintained a relatively stable state, allowing humanity to flourish and evolve. However, the rapid industrialization and exponential growth in human population and activities since the mid-20th century have pushed the Earth beyond its natural limits. We have inadvertently crossed numerous critical thresholds or planetary boundaries that are crucial for maintaining the Earth in a state conducive to human habitation. In the original 2009 framework, 9 planetary boundaries were identified, covering a range of environmental issues such as climate change, biodiversity loss, land use change, and more. These boundaries are not isolated, they interact and influence one another. For instance, altering climate patterns can affect biodiversity, and changes in land use can exacerbate climate change. While the concept of planetary boundaries helps us understand the delicate balance that our planet has maintained for millennia, it also serves as a wake-up call. It urges us to take a step back, reassess our impact on the Earth, and work collectively to preserve and restore the balance that has sustained life for so long. Understanding and respecting these planetary boundaries is paramount for creating a sustainable future. It necessitates a paradigm shift in how we approach development, resource utilization, and conservation. Humanity needs to act responsibly, ensuring that we operate within the safe space defined by these boundaries to guarantee a livable planet for current and future generations. Understanding Earth's health check. In this section, we delve into the recent study assessing Earth's health through the Planetary Boundaries Framework, exploring the parameters and implications of the research. The breached planetary boundaries represent an overstep of the Earth's natural limits, indicating unsustainable human activities and their detrimental impact on our environment. These breaches serve as red flags, warning us that our actions are endangering the stability of our planet. Let's examine each of the breached boundaries in detail. Climate change. Climate change is one of the most critical challenges we face today. Rising greenhouse gas emissions, primarily carbon dioxide from burning fossil fuels, have led to a warming planet. This warming disrupts weather patterns, causes extreme events, and accelerates the melting of ice caps and glaciers. Mitigating climate change requires substantial reductions in emissions and transitioning to renewable energy sources. Biosphere integrity, biodiversity. Biodiversity, a cornerstone of Earth's health, is rapidly diminishing due to habitat destruction, pollution, climate change, and over-exploitation. Loss of biodiversity disrupts ecosystems, weakens resilience, and threatens essential services like pollination and nutrient cycling. Conservation efforts and sustainable land use are crucial for preserving biodiversity. Freshwater availability. Water is a finite resource, and overuse and contamination have placed immense stress on freshwater systems. Pollution, urbanization, agriculture, and climate change further exacerbate this issue. These breaches highlight the extensive impact human activities have had on the delicate balance of Earth's systems. The study does not convey these breaches as points of no return. Rather, they are stark warnings, akin to elevated blood pressure indicating a heightened risk of a heart attack. It's a call to action, an alarm that the risk is dangerously high, compelling us to act decisively and with urgency. The severity of the breaches is particularly pronounced in the biological boundaries, which encompass biodiversity. This reveals a distressing reality. We are altering the very fabric of life on Earth. The rampant loss of biodiversity, largely attributed to habitat destruction, climate change, pollution, and over-exploitation, has far-reaching and often irreversible consequences for ecosystems and the services they provide to humanity. This health check for our planet, based on the Planetary Boundaries Framework, is not a mere academic exercise. It is a call to every individual, community, organization, and government to recognize the gravity of our current trajectory. It emphasizes the need for collective responsibility, sustainable practices, and bold policy decisions to steer us back within the safe operating space that our planet has historically provided. The breached boundaries, an overview. Responsible water consumption, efficient agricultural practices, and wastewater treatment are imperative to ensure freshwater availability for all. Land use. Human activities, including agriculture, urban expansion, and deforestation, have dramatically altered the Earth's land surface. Land degradation, loss of natural habitats, and deforestation contribute to climate change, biodiversity loss, and soil erosion. Sustainable land management and reforestation are vital for restoring and preserving our land resources. Nutrient pollution. Nutrient pollution, primarily from excessive use of nitrogen and phosphorus-based fertilizers, disrupts aquatic ecosystems, causing harmful algal blooms and dead zones in oceans and lakes. Proper nutrient management in agriculture and wastewater treatment can mitigate this pollution and safeguard water quality. Novel entities, human-made pollution. Human-made pollutants, including microplastics, synthetic chemicals, and radioactive waste, pose substantial risks to both ecosystems and human health. Effective waste management, reduction of single-use plastics, and responsible handling of chemicals are essential steps to mitigate this pollution and safeguard our environment. Addressing these breached boundaries requires global cooperation, innovative solutions, and a profound shift in how we interact with our environment. It demands a transition to sustainable practices that prioritize the preservation of our planet and the well-being of all its inhabitants. Biosphere integrity and biodiversity. In this section, we'll delve into the critical importance of biodiversity and the alarming levels at which it's being compromised due to human activities. Biosphere integrity, often encompassed within the broader term biodiversity, represents the variability and variety of life forms on Earth. This includes the diverse array of species, ecosystems, and genetic material they contain. Biodiversity plays a fundamental role in maintaining the equilibrium of the Earth's systems and is directly linked to the health and resilience of our planet. Understanding biodiversity's importance. Ecosystem stability. Biodiversity contributes to ecosystem stability and resilience. Diverse ecosystems are better equipped to withstand and recover from disturbances like climate change, diseases, and natural disasters. Economic value. Biodiversity underpins many industries and economies. It provides food, medicine, materials, and ecotourism opportunities. The loss of biodiversity can disrupt these vital sectors. Genetic diversity. Genetic diversity within species is crucial for adaptation and resilience against changing environmental conditions. It ensures species can evolve and survive in varying habitats. Pollination and agriculture. Biodiversity, particularly pollinators like bees, is critical for successful crop production. Reduced biodiversity can lead to lower agricultural yields and disrupt food security. Alarming trends in biodiversity loss. Human activities such as habitat destruction, pollution, overfishing, and climate change have led to a rapid decline in biodiversity. The rate of extinction of species is currently estimated to be 100 to 1,000 times higher than the natural extinction rate. Mass extinctions. Earth has witnessed 5 mass extinctions in its history, primarily due to natural phenomena. The current loss of biodiversity is often referred to as the 6th mass extinction, largely caused by human activities. Habitat destruction. Habitat loss and fragmentation are among the leading causes of biodiversity decline. Urbanization, agriculture, and infrastructure development result in the destruction and isolation of habitats. Invasive species. The introduction of non-native species into new ecosystems can outcompete or prey on native species, leading to their decline or extinction. Climate change impact. Climate change alters habitats and affects the distribution, behavior, and life cycles of numerous species, often faster than they can adapt. The urgent need for conservation and restoration. Conservation efforts are vital to mitigate biodiversity loss. This includes establishing protected areas, implementing sustainable land and resource management practices, and addressing climate change. Furthermore, restoration initiatives that aim to revive degraded ecosystems and habitats are gaining importance. Reforestation, habitat rehabilitation, and species reintroduction programs can help restore biodiversity and support Earth's recovery. The alarming loss of biodiversity underscores the urgency to act collectively and swiftly. It's imperative to recognize biodiversity as a shared global asset and make conscious efforts to protect and restore the rich tapestry of life on our planet. Climate change and its far-reaching impact. In this section, we'll delve into the planetary boundary of climate change, its causes, consequences, and the urgent need for global action to mitigate its effects. Climate change, driven predominantly by human activities, is one of the most pressing challenges facing our planet. It is a prime example of how our actions can breach planetary boundaries and have far-reaching and detrimental effects on the Earth's systems and all life forms. Understanding climate change. Greenhouse gas emissions. Human activities such as burning fossil fuels, coal, oil, and gas, deforestation, and industrial processes release greenhouse gases like carbon dioxide, CO2, methane, CH4, and nitrous oxide, N2O, into the atmosphere. Enhanced greenhouse effect. These greenhouse gases trap heat in the Earth's atmosphere, leading to an enhanced greenhouse effect. While this is a natural phenomenon, human-induced activities have significantly intensified it. Rising global temperatures. The enhanced greenhouse effect results in a warming of the Earth's surface, leading to global warming and altered climate patterns, commonly referred to as climate change. Consequences of climate change. Extreme weather events. Climate change intensifies extreme weather events like hurricanes, floods, heat waves, and droughts, causing widespread devastation and loss of life. Melting ice and rising sea levels. Higher temperatures cause the melting of glaciers and polar ice caps, contributing to rising sea levels. This poses a significant threat to coastal communities and ecosystems. Biodiversity loss. Climate change disrupts ecosystems and habitats, impacting the distribution, behavior, and survival of various species, often leading to biodiversity loss. Food and water security. Changes in temperature and precipitation patterns affect agriculture and water availability, threatening food security for many communities. Health impact. Climate change exacerbates health issues by influencing the spread of diseases, increasing the frequency of heat-related illnesses, and impacting mental health due to extreme events. Mitigating climate change, a global imperative. Addressing climate change requires urgent, ambitious, and collaborative action on a global scale. Key strategies include transition to renewable energy. Shifting from fossil fuels to renewable energy sources like solar, wind, and hydroelectric power is critical to reduce greenhouse gas emissions. Energy efficiency. Enhancing energy efficiency in industries, transportation, and buildings reduces energy consumption and lowers emissions. Reforestation and afforestation. Planting trees and restoring forests can sequester carbon dioxide and mitigate climate change. Climate policies and agreements. International agreements and national policies that prioritize climate action and emission reduction are essential. Sustainable practices. Adopting sustainable lifestyles, promoting circular economies, and reducing waste contribute to mitigating climate change. Tackling climate change is imperative for safeguarding our planet's future and the well-being of all its inhabitants. Every individual, community, and nation must actively participate in this global endeavor to ensure a sustainable and habitable world. The Global Water Challenge, freshwater availability. Freshwater, a finite and vital resource, sustains life and plays a fundamental role in various human activities. However, increasing population, pollution, climate change, and unsustainable usage have placed immense stress on global freshwater resources, breaching the planetary boundary of freshwater availability. Understanding freshwater scarcity. Growing demand. As the global population expands, the demand for freshwater for drinking, sanitation, agriculture, and industrial processes has surged, often exceeding sustainable levels. Pollution. Pollution from industrial discharges, agricultural runoff, and inadequate wastewater treatment contaminates freshwater sources, making them unusable or harmful to health. Climate change impact. Climate change alters precipitation patterns, leading to droughts or excessive rainfall in certain regions, disrupting the balance of freshwater distribution. Wasteful usage. Inefficient irrigation practices, water leakages, and wasteful domestic consumption contribute to the depletion of freshwater resources. Consequences of freshwater scarcity. Health impact. Inadequate access to safe fresh water can lead to waterborne diseases, posing a significant threat to public health. Agricultural challenges. Agriculture, a major consumer of fresh water, faces reduced crop yields and food security issues due to water scarcity. Ecosystem disturbance. Depletion of fresh water affects aquatic ecosystems, leading to habitat loss and declining biodiversity. Socioeconomic implications. Widespread clearing of forests for agriculture, logging, and urban development disrupts ecosystems and contributes to climate change. Infrastructure development. Roads, dams, and other infrastructure projects modify landscapes, fragment habitats, and alter natural drainage systems. Environmental impact of land use changes. Biodiversity loss. Land use changes are a primary driver of biodiversity loss, with many species losing their habitats and facing heightened extinction risks. Climate change contribution. Deforestation releases stored carbon dioxide, a major greenhouse gas, into the atmosphere, contributing significantly to climate change. Soil degradation. Intensive agriculture and poor land management practices can lead to soil erosion, nutrient depletion, and desertification. Water cycle disruption. Altering land surfaces affects the water cycle, leading to changes in rainfall patterns, increased runoff, and altered groundwater levels. Sustainable land management practices. Sustainable agriculture. Adopting practices like crop rotation, agroforestry, and reduced pesticide usage can mitigate the environmental impact of agriculture. Reforestation and afforestation. Planting trees and restoring forests can counterbalance deforestation and enhance carbon sequestration. Smart urban planning. Encouraging compact and sustainable urban development minimizes the environmental footprint associated with urbanization. Land use zoning and regulations. Implementing zoning laws and regulations that guide responsible land use can protect natural habitats and ensure sustainable development. The dilemma of nutrient pollution, a threat to water systems. Nutrient pollution is a significant planetary boundary breach affecting water systems globally. It occurs when excessive amounts of nutrients, primarily nitrogen and phosphorus, are introduced into water bodies, leading to detrimental impacts on both aquatic ecosystems and human health. Understanding nutrient pollution. Sources of nutrients. Nutrients primarily come from agricultural runoff, wastewater discharge, industrial emissions, and improper disposal of human waste. Agricultural runoff. The excessive use of fertilizers in agriculture is a major source of nutrient pollution, as rainwater carries these nutrients into rivers and lakes. Wastewater discharge. Untreated or poorly treated wastewater from households, industries, and sewage systems can contain high levels of nutrients. Consequences of nutrient pollution. Algal blooms. Nutrients promote the rapid growth of algae in water bodies, leading to harmful algal blooms, which can produce toxins harmful to aquatic life and humans. Dead zones. Algal blooms consume oxygen when they decompose, leading to oxygen-depleted dead zones in water bodies where marine life struggles to survive. Biodiversity impact. Nutrient pollution alters aquatic ecosystems, affecting the distribution and behavior of species, often leading to declines in biodiversity. Human health risks. Consuming contaminated water or seafood from nutrient-polluted areas can pose health risks, including gastrointestinal issues and neurological disorders. Sustainable nutrient management. Agricultural best practices. Implementing precise fertilizer application, crop rotation, cover cropping, and agroforestry can reduce nutrient runoff from agricultural activities. Wastewater treatment. Upgrading wastewater treatment plants and promoting decentralized treatment systems are crucial steps in minimizing nutrient pollution from human waste. Public awareness. Educating the public about the impacts of nutrient pollution and the importance of responsible nutrient use and disposal is essential. Policy and regulation. Enforcing regulations on nutrient discharge from industries and setting limits on nutrient levels in water bodies are vital steps to combat nutrient pollution. Addressing nutrient pollution requires a holistic approach involving agriculture, industry, government, and individuals. By adopting sustainable nutrient management practices, we can protect our water systems and ensure a healthier environment for all. Novel entities, unveiling the impact of human-made pollution. Human-made pollution. Novel entities include a wide range of substances like microplastics, synthetic chemicals, pharmaceuticals, heavy metals, and radioactive waste, among others. Sources of pollution: industrial processes, improper waste disposal, inadequate recycling, and unrestrained use of certain materials contribute to the introduction of novel entities into the environment. Environmental and health impact: marine and aquatic life. Microplastics and toxic chemicals pose a significant threat to marine life, leading to ingestion, habitat destruction, and bioaccumulation up the food chain. Air quality and respiratory health. Industrial emissions and pollutants like particulate matter, PM, and nitrogen oxides, NOx, contribute to poor air quality, affecting respiratory health in humans. Soil contamination. Improper disposal of industrial waste and chemicals contaminates soil, rendering it infertile and harmful to plants and organisms. Mitigating the impact of novel entities. Waste management. Proper waste disposal, recycling, and responsible handling of hazardous materials are essential to reduce the introduction of novel entities into the environment. Regulation and monitoring. Governments and regulatory bodies need to enact and enforce laws to control the use and disposal of harmful chemicals and materials. Promoting sustainable products. Encouraging the production and use of eco-friendly, biodegradable, and recyclable products can significantly reduce the impact of novel entities. Public awareness and education. Educating individuals about the dangers of improper waste disposal and the use of harmful substances is crucial for behavior change. The environmental challenges of ozone depletion. Understanding ozone depletion. Ozone layer structure. The ozone layer is mainly situated in the lower portion of the stratosphere, approximately 10 to 30 kilometers above Earth's surface. Depleting agents. Chlorofluorocarbons, CFCs, halons, carbon tetrachloride, and other similar compounds are primary contributors to ozone layer depletion. Impact of depletion. Thinning of the ozone layer allows more UV radiation to reach Earth's surface, leading to increased cases of skin cancer, cataracts, and other health issues. Ongoing efforts and mitigation. Montreal Protocol. The Montreal Protocol, adopted in 1987, is an international treaty designed to phase out the production and use of substances that deplete the ozone layer. Alternative technologies. The phase-out of ozone-depleting substances has led to the development and adoption of eco-friendly alternatives like hydrofluorocarbons, HFCs. Public awareness. Raising awareness about ozone layer depletion and its consequences has spurred global action and individual responsibility towards protecting the environment. Future outlook and challenges. Complete recovery. While the ozone layer has shown signs of recovery, complete restoration will require sustained efforts and compliance with international agreements. Emerging threats. New substances and practices may pose threats to the ozone layer, necessitating continuous research and vigilance. Preserving the ozone layer is a testament to international cooperation and the impact of global agreements. By remaining vigilant and proactive, we can ensure a healthier atmosphere and a safer planet for all. This concludes our exploration of the planetary boundaries concerning Earth's health and sustainability. The challenges we face are interconnected and require a collective effort to address effectively. Stay informed, take responsible actions, and advocate for a sustainable future. Together, we can make a difference. For more in-depth insights and updates on this critical topic, explore reputable scientific journals and organizations dedicated to environmental research and conservation. Stay tuned for our upcoming series where we dive deeper into specific environmental issues and potential solutions. Thank you for your interest and commitment to a better world.